This will be a follow-up video on the last video we had on special substitutions for integrands involving a rational expression of sine and cosine. So in the last video, I went through the substitutions. U equal sine of x over 1 plus cosine of x, and that's equal to tangent of x over 2. So the u in this particular case then is going to be sine x over 1 plus cosine of x. Now this is a trig identity right here for the tangent of x over 2. I will link or put a link in the description for the last video just in case you didn't see this, but these are the formulas that I derived. So like I mentioned in the last video, it works best when you don't have any trig functions in the numerator. You can have a linear combination in the denominator, 1 plus 3 sine of x plus cosine of x, nothing squared. So where you have a cosine, if you use this method here, you plug in 1 minus u squared over 1 plus u squared. If you have a sine of x, you put in 2u over 1 plus u squared. And of course, if that's multiplied by a constant, you put those in also. And then the dx, using the substitution, and we showed this last time, is dx over, or dx equal to 2 du over 1 plus u squared. Now for the other substitution, we went over that one briefly. Weierstrass substitution, we use t equal to tangent of x over 2, and this is what we derived in the last video. So if you use this method, the tangent of x over 2 substitution, there's your dx. We derive the cosine of x over 2 because that's what we get. That's what we have because of this angle here. But we needed sine of x, and I derived that last time. Sine of x is 2t over 1 plus t squared. Cosine of x is 1 minus t squared over 1 plus t squared. So the difference here again, in the first substitution, you integrate in terms of u, and wherever have a u in the answer, you're going to put sine of x over 1 plus cosine of x. Now for this method, if we use this method, you integrate with respect to t, and at the end, when you finish with the integration, where you have a t, you go back to the original variable, but that's going to be tangent of x over 2. Okay, so here's what we have. Here's the problem we're going to look at. Now I said it works best if you just have sine of x and cosine of x. Just to give an example of one that doesn't have those situations, you have sine of x in the denominator minus tangent of x. So all we did here is, let's put it in terms of sine and cosine because those are what the formulas are for. So I just multiplied the tangent of x here by cosine. So we got sine of x times cosine of x, and then the tangent of x times cosine. The cosine cancels, and I get minus sine of x. And then, of course, in the numerator, you get cosine of x. That's all we did. We took this given integral. We're evaluating this integral here. Multiply the numerator by cosine of x, the denominator by cosine of x, and that's what we got right there. And then all I did in the second step right here, first multiplied by cosine of x, we got this, numerator and denominator. And then all I'm doing now is just plugging in what we got for cosine of x. For cosine of x, we got 1 minus u squared over 1 plus u squared. And then the dx, that was 2 du over 1 plus u squared. And then denominator, same thing. Replace the sine of x by what do we got? 2u over 1 plus u squared. That's our special substitution, or one of them. For the cosine, you plug in 1 minus u squared over 1 plus u squared. And then again for the sine, same thing over here. Minus, then sine is equal to 2u over 1 plus u squared. Then all we did here, we're going to do is just simplify this out. So here's what we're going to do. We're going to multiply numerator and denominator by 1 plus u squared. Notice we have 1 plus u squared here, 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 everywhere here. We're going to multiply by 1 plus u squared squared. So what is that going to give us then? In the numerator, got 1 plus u squared, 1 plus u squared. That's going to cancel out, divide out. So it's going to give us 2u times 1 minus u squared. So this will be a minus 2u squared minus 2. So it's just multiplying here. The denominators canceled out because of this here. So minus 2u squared, and this is a plus 2 here. Denominators canceled. Still got the du over here. And then for this one here, again, 1 plus u squared times 1 plus u squared. That cancels the 1 plus u squared over here. So that gives me a 2u times 1 minus u squared. This product divided out with this. Now the denominator, of course, remember, is also multiplied by the 1 plus u squared. And then for this one here, 1 factor of 1 plus u squared divided out. But it's still got 1 left over here. So this will be 1 plus u squared. Now the rest of it is just algebra. So this will be, let's multiply through, we get a minus 2 multiplying here, distributing minus 2 u to the third plus 2u. Multiply here, distribute, get a minus 2. It's just a 2u here. So minus 2u times 1 would be minus 2u here. And minus 2u times a u squared here is a minus 2u cubed. So this is equal to, on top we have a minus 2 u squared plus 2. The bottom here we get a minus 2u cubed and a minus 2u cubed. That's a minus 4u cubed. And then a minus 2u and a minus 2u, that divides out, cancels out, goes to 0. So we got this. So it's just going to equal to, it should be 1/2 here. Minus 2 and minus 4 is just a 1/2, and then u squared, u to the third, that'll give me a u down here. That'll be a minus 1/4 for the next one. And this will give me a u. I'll take the u to the third to the numerator, be minus 3 here. We're going to go over here. This is equal to then the integral of 1 over 2. You look at that, you can take out the 1/2, and that's the integral of, let me write it this way, there's 2 integrals here, du. To be 1/2 du over u, but that's your natural log. So that's 1/2 natural log of absolute u. And for this one, basic integration, add 1 to the negative 3. And this one reduced to minus 1/2 here. And now add 1 to the negative 3, we get negative 2. Divide over here, that's the positive 1/4 u to the negative 2. And then this is equal to 1/2 ln of u plus 1/4 u to the negative 2 plus the constant of integration. Now, this is the answer. This is the answer in terms of u. Now all we have to do is replace the u by what it's equal to. So the u was sine of x over 1 plus cosine of x. So go back, and where the u is here, we have 1/2 natural log of u. We put in sine of x over 1 plus cosine of x. And then it's plus 1/4 u to the negative 2 plus c, and the u is replaced by sine of x over 1 plus cosine of x. And that's how we get this part right here. I have u, and this is u, to the negative 2 power. And then it was the 1/2. I have them in reverse here, but it's the same thing. First I had it 1/2 natural log of u. So I replaced the u by sine of x over 1 plus cosine of x. And this was 1/4 u to the negative 2. Again, the u is replaced by sine of x over 1 plus cosine of x, plus the constant of integration. And then to go to this step here, just apply the law of exponents. Got a negative exponent here, flip it, this changes. Okay, so this and this are the same thing, except now I have a positive exponent. So the sine goes to the denominator, 1 plus cosine x goes to the numerator, there you have it. And then this is the same, 1/2 log, natural log of absolute sine of x over 1 plus cosine of x. And that's the answer using the first substitution. Now let's suppose I'm going to look at the same problem again, except in this case, instead of a u, I have a t. So the t is going to equal to tangent of x over 2. And again, I derived these formulas in the last video, and there will be a link in the description in case you want to refer to that. But through this right triangle, this is what we got last video. First we found the sine of x over 2, and then we got the sine of x, because that's what the problem has. It doesn't have sine of x over 2, it has sine of x. Same thing for the cosine. First we got cosine of x over 2 over here. And then using some basic identities, we got cosine of x is 1 minus t squared over 1 plus t squared. Now if you look at the formulas, the one we just used, the u one, with a u, they're pretty much the same, except instead of a t, instead of a u, they're a t. But we're going to do the same thing. Wherever you have a sine of x, you're going to replace it by 2t over 1 plus t squared, except in this case, the t is tangent of x over 2. Wherever you have a cosine of x, it's going to be 1 minus t squared over 1 plus t squared. And the dx is going to be replaced by 2 over 1 plus t squared dt. Now this is the same. I'm going to pick it up here with the same situation. We multiplied by cosine of x to get rid of the tangent in the denominator. And this is what we got. Notice it looks the same. It is the same. The only difference is instead of a u, you have a t. The cosine of x is replaced by 1 minus t squared over 1 plus t squared using those substitutions. The dx is 2 dt 1 plus t squared instead of 2 du 1 plus u squared. Exactly the same thing. All you do is go back and replace the t by the u by t, and there you have it. Then you do the same thing here, except instead of u is t. Multiply numerator and denominator by 1 plus t squared, quantity squared. And you're going to simplify the answer the same way. So you can do the algebra here, but it's going to be the same thing. It comes out to the integral of 1 over 2t. So you can go back to what I just did, what I presented, and put a t instead of a u. And it's going to come out to the integral of 1 over 2t minus 1/2 t to the negative 3. This is the same thing we had a while ago, except it's with a t instead of a u. But this is still going to come out. This is still going to come out to the natural log of absolute t. Still got the 1/2 out in front. Add 1 here, negative 2 and divide, we get a plus 1/4 t to the negative 2, plus the constant of integration. Now the only difference is what we write next. This is still going to be 1/2. Remember, using the other substitution, we went back to the value of u. Well, in this case, it's the substitution for t. So for this one here, it's the tangent of x over 2. 1/2 natural log of tangent of x over 2 plus 1/4. This is to the negative 2 here. We add 1 to this one, negative 2 and divide. And this was the negative 2 here. So 1/4 t to the negative 2, but t is tangent of x over 2. Now you can use identities for tangent of x over 2 if you want to rewrite this in a different form. But why would you? I would just leave it this way. Notice the answer is different because the other one was a different substitution. But they're both correct. You take the time. It's going to take you some time to check it. Both answers should check. If you take the derivative, you should get the original function. But for this one here, using the second substitution, the tangent of x over 2, t equal tangent of x over 2, we get the 1/2 natural log of absolute tangent of x over 2 plus 1/4 the tangent of x over 2 to the negative 2 plus the constant of integration. Thanks for watching, and we'll see you next time.